On the surface of Mars, we have compelling evidence of the presence of liquid water during its past. Most of this water activity was concentrated between these two geologic epochs, which are called Noachian and Hesperian, and they go approximately between 4 billion years ago to 3 billion years ago. However, we have an extremely wide range of water-related processes that took place in this time span between these two epochs. In particular, during the Noachian, we have fluvial valleys, we have craters with lakes and deltas, and at the same time we had the formation of clay minerals that altogether indicate that water was abundant at the surface. On the other hand, during the Hesperian, the environment started to transition towards a drier climate, and we have the build-up of several evaporate minerals, especially sulfate, which usually form as large bodies of water evaporate. This all indicates that water had started to disappear. How this happened and what was the exact characteristics of the Noachian Hesperian climatic transition, it is actually something which is still discussed and debated today.
On Mars, since we don't have plate tectonics, sedimentary rocks at the surface are an important archive of climate changes on the planet. And in particular, on this area of Mars, which is called Meridiani Planum, we have a very interesting set of units, which are sedimentary units that build up between the end of the Noachian and the beginning of the Hesperian, and they are rich in hydrous minerals. There are many hypotheses for the formation of these layered materials, which are usually called equatorial layered deposits because they are found at the equatorial latitudes of Mars. The most accepted hypothesis is the fact that they form through groundwater upwelling, but there are also other proposed hypotheses like for example, a volcanic airfall origin or an origin related to dust and ice. So it is still quite debated how these features have formed. So the main objective of the research is to characterize the mineralogy and stratigraphy of these layered units at high resolution. What we wanted to do is to help constrain their formation mechanism and derive possibly implications on Mars' ancient climate. The interesting thing that we have found is that these beds of these layered deposits are alternating between clay-dominated beds and sulfate-dominated beds cyclically. We propose that these layered materials have formed in a groundwater-fed lacustrine environment where in periods of higher water abundance, the beds were deposited with more clay-dominated mineralogy. Whereas when we have periods of less water abundance, the evaporate minerals dominate the stratigraphic sequence. And since we found these beds that alternate between clays and sulfates, it is likely that what happened is that we had oscillation of the water table inside these craters.
The clay minerals that we have found are clays rich in iron and magnesium, and in one case we also have found aluminum-rich clays in this crater where we also have observed thinner beds. The craters are found in 3 different areas of Meridiani Planum, and in particular the crater where we have found aluminum-rich clays is in a more upland position with respect to the other craters. And what we think has happened here is that due to its position, this crater was more sensible to high frequency oscillations of the water table.
With that, we were able to put a substantial constraint on the formation mechanism of these layer deposits. In addition, we also have a record of water oscillations and climate oscillations. The Hesperian Noachian climatic transition was likely characterized by several oscillations and was not a steady transition. We likely had these oscillations between more water-rich periods and drier periods, and the equatorial layer deposits are an important evidence of that.